Hello, my name is Dominic Moderman. I am the project manager for Passport VR in fall 2018. Me and my team have been working out of DAGD 340 Junior Project and are proud to share what we were able to produce with you. The goal of Passport VR is to create an educational tool for the GRCC Geology program. It seeks to create an educational experience that can help at-risk or low-income students learn about geology in preparation for a study abroad course. The purpose of this iteration of Passport VR was to create a proof of concept that Michael Caluzzi will build upon during the spring of 2019 when he is enrolled in Capstone. I tried to make sure that we had everything we needed to get this project completed, that everybody had a reasonable workload, and that we were moving along according to schedule. Jessica was originally assigned the task of QA director, but she ended up handling research, as well as any miscellaneous tasks thrown her way. She was vital to us nailing down a solid direction for this project, and jumped in and followed through on whatever was assigned to her. Jacob was assigned the role of lead 3D artist. He dove headfirst into photogrammetry and has consistently produced extremely high-quality 3D assets at an alarming rate. Andrew was one of our programmers, or VR engineers. He has helped develop interactive activities and visual effects. He has also done research, creating proof of concepts for UI and user interaction. He has created some amazing effects and helped us understand what our options are regarding user interaction as we move forward. Logan was our second programmer and VR engineer. He pulled all-nighters to get our project ready by November, and he has been the driving force behind our interactive activities, making sure that our project runs in VR. Without these efforts, we would have never been able to achieve the level of success that we have enjoyed on this project. We utilize photogrammetry to create photorealistic 3D renderings. We use this both for geological samples and for geological features. Modeling was handled in 3ds Max, and retopology, or Z-remeshing, was done in ZBrush. The Unreal Engine is where everything was built and run out of. The specific requirements of this project were left relatively ambiguous at the outset. We weren't sure how many photogrammetric locations there were going to be, and how many samples we were going to need. We weren't sure how many interactive activities we were going to have, or what those activities were going to be for that matter. As the project progressed, we decided to go with a single photogrammetric location from Grand Ledge and 2 to 3 interactive activities in a separate lab location. For the interactive activities, we decided to develop a measuring tape, a planes of cleavage demo, and a scratch plate demo. Let's take a look at what we were able to produce. The measuring tape would allow users to measure geological features and eventually perform operations such as a strat column, where the depth of various rock layers are measured and recorded. We were successful in demonstrating the viability of this feature. The second was the planes of cleavage demo. This visualizes the planes along which rocks are likely to cleave or break. This is a very abstract concept that we were able to visualize using virtual reality. The scratch plate demo would help students understand rock hardness by replicating the mole hardness test, where items of various hardness are rubbed against a rock to see if they produce a scratch. This activity was ultimately left incomplete, but components that Caluzzi will be able to take advantage of were developed. Photogrammetry turned out to be much more accessible than originally anticipated, and by the end of our first month, we were able to get a viable mesh generated. Overall, I would say that we have been successful. Since our first week, we have made steady progress towards our goal. Our first functional prototype was ready the first week of November, and I am proud of the effort that the team has put forth and the product that we were able to produce. In conclusion, we were able to create a solid proof of concept that Caluzzi will be able to build on next semester. I can't wait to see how far this thing gets taken in Capstone and beyond.